Hi. The loop transfer function of a unity negative feedback system is given the value of k for which the system is marginally stable. So there are two methods for solving this question. So first we will discuss about the method 1. So to solve this problem, we have to use the RH criteria, route Harbison criteria. So for that, the first we have to form the characteristic equation. So the characteristic equation of a negative feedback system is given as 1 plus g of s into h of s is equivalent to 0. Now given that g of s and h of s as k into s plus 11 by s into s plus 2 into s plus 8 is equivalent to 0. Now by solving this, s square plus 2s into s plus 8 plus k into s plus 11 is equivalent to 0. Now by solving this, s cube plus 10 s square plus 16s plus ks plus 11k equal to 0. Now this is in terms of s cube plus 10 s square plus, by taking the s common, as 16 plus k plus 11k equivalent to 0. Now to find this, whether the system is marginally stable, so we should form the RH criteria. So RH criteria, first write down the s cube coefficient as 1. After that we have to write the s power 1 coefficient, that is 16 plus k, and write down the s square coefficient 10, and then s power 0 coefficient 11k. Now after that, s power 1 is obtained by multiplying the 10 into 16 plus k minus 11 into 1, 11k, divided by this 10. Now this coefficient will obtain as 0. Now s power 0 coefficient will be multiplication of this into this minus 10 into 0 divided by this one, means 11k. Now after getting this, if the system is said to be marginally stable, means any one of the row in a RH criteria should be 0. Now so this one, s power 1 coefficient, involves the k, means this value should become 0. Now k, so 10 into 16 plus k minus 11k equal to 0 for the system is marginally stable. So from this, 160 plus 10k equal to 11k. So from this, k is equal to 160 is the value for the system is said to be marginally stable. This is the answer. Now we will discuss another method 2. So what the characteristic equation we obtained here, s cube plus 10s square plus s into 16 plus k plus 11k equal to 0. So this method 2 is, this is the outer, this is the inner. So the inner coefficients, this is inner coefficient. What are the inner coefficients? 10 into 16 plus k, and outer coefficients, outer 1 into 11k. So inner coefficient, the product of inner coefficients is equivalent to the outer coefficients. So the outer coefficients 1 into 11k, 11k is equal to, inner coefficients are 10 into 16 plus k. So from this, 11k equal to 160 plus 10k. So from this, k is equal to 160. This is the another method we obtained by doing the only 3 steps. So this is the final answer. The answer for this question is k is equal to 160. The system is marginally stable. Thank you.